Okay, so let's review rational exponents and properties of rational exponents. They're the same as just integer exponents. It's just now they're fractions, so don't go crazy. So this ratio, you'll recognize this. This just means we're talking about fractions. Okay, something compared to something else. So on the other side, we were writing the index, this number on the bottom, so I can say that that's the index. It's the same thing as going from exponential form to radical form. Whatever number is on top is the power. Whatever number is on bottom is the index. Now this can be written one of two ways. I could say that the index is here and the power is here. Or I could say the index is here and the whole thing is raised to some power. And we're assuming that if m is negative, that a is not equal to 0. Okay. So if we have these in exponential forms, all the laws of exponents still apply. So if I have something with the same base and I'm multiplying them, all I'm going to do with the exponents is add them together, m plus n. So here we have 8 1/3 times 8 2/3. My base, my a is 8. So I have 1/3 plus 2/3. We get 3/3, which is the same as 8 to the power of 1. If I have something with an exponent that I'm raising to another exponent, I'm going to multiply the two numbers together. So here my base is 5. I have these two exponents, so I have 5 1/2 times 4. This is the same as 4/2, which is the same as 2. If there is an exponent out here, this exponent applies to every term. Now this means variable or number. And number. Variables and numbers. Okay. So this would result in a to the power of m, b to the power of m, meaning this would be 1/2 to each of these, 4 to the 1/2 times 5 to the 1/2. This just means the square root of 4, that's just 2. And 5 is not a perfect square, so we would just leave that. Now, negative exponents, we've been talking about inverses. This just means whatever number is here will be made positive. If it's in the numerator, it will become positive in the denominator. So if I have something like this, this would in turn mean I just have it positive this way. So for a 9 to the negative 1/2, this is the same thing as 1 divided by 9 to the power of 1/2. This is the same thing as the square root of 9. And we all know that is 3. Okay? Right, if I have the same base and I'm dividing, this is the same as subtracting the top number minus the bottom number. So whatever it is, whether it's a number, a variable, something such as pi, we have pi 3/2 minus 1/2 in the exponent. 3/2 minus 1/2 is just going to be 2/2, which is just the same thing as pi to the power of 1, just the same as pi. And again, we have an exponent on the outside, so this would become a to the m divided by b to the m when this exponent is distributed to each term. So here I would have 8 to the 1/3, 27 to the 1/3, meaning cubed root of 8, which would be 2, This means cubed root of 27, which would be 3, okay? So all of the properties of integer numbers, meaning whole numbers, apply to rational exponents. Okay? So to write an expression with rational exponents in the simplest form, we're going to reduce any exponents, any fractions we've got. We want only positive exponents. And I want one of each variable or constant, meaning number. Okay? Oop. Missed all that. Okay, so for example, let's say I had 3x squared y divided by 9x. Well, I've got a few variables here. I've got a y, and I've got this x. And then I've got these constants, these numbers, this 3 and this 9. Okay, so I have x squared on the top. I'm going to reduce that. I'm going to take one of these x's from here and one of these x's from here, so I just have an x on the top. I only have one y, so that's not going to reduce. And then when I reduce a 3 and the 9, so if I divide this by 3, it will cancel. If I divide this by 3, I'll have a 3. Could say I have a 1 here. Positive exponents, one of each variable or constant, and I reduced any fractions. This one doesn't happen to have any.